On one side of the world, a single missile strike just wiped out 17% of a nation's energy exports overnight. And then on the exact same day, a $4 billion data center is rising from the toxic ashes of a dead Kentucky aluminum smelter.
Yeah, the contrast right now is just unbelievable.
It really is. Welcome to Scaling Legends. If you are a construction business owner, a project manager, or an industry professional, you are probably navigating absolute whiplash right now. Today's deep dive is about surviving this exact moment in March 2026, where violent geopolitical shocks are just colliding head-on with domestic mega projects and rapid technological shifts.
Right, because you can't really look at these things in isolation anymore. They all bleed into each other.
Exactly. Okay, let's unpack this. We need to start with the geopolitical shockwave because the sheer scale of this it's hard to overstate. On March 18th, an Iranian missile struck Qatar's Ras Laffan industrial city. 5 missiles were fired, 4 were intercepted, but 1 got through, hitting and severely damaging LNG trains S4 and S6.
And the fallout from that single impact is just staggering. I mean, it instantly knocked 12.8 million tons per annum offline. Like you said, that is 17% of Qatar's liquefied natural gas export capacity. Just gone.
Wow.
Yeah, and the Qatar Energy CEO is estimating a repair timeline of 3 to 5 years. That results in a $20 billion annual revenue loss.
Wait, okay, before we go further into the construction impacts of that, let's clarify the immediate market reaction, because we saw that European TTF gas prices surged 17% in hours, while exports of condensate and LPG just plummeted. For those of us outside the immediate energy sector, what do those terms actually mean in a practical sense?
That's a great question. So TPS stands for Tidal Transfer Facility. It's essentially the virtual trading point in the Netherlands that acts as the heartbeat for all European natural gas prices.
Okay, so when TTF spikes, basically heating and manufacturing costs across Europe skyrocket.
Precisely. And then you have condensate, which refers to ultralight liquid hydrocarbons, and LPG, which is liquefied petroleum gas. So things like propane and butane. These are critical feedstocks for plastics, petrochemicals, heating, you name it. When Qatar loses 17% of its capacity, the global supply of the raw materials that run modern manufacturing shrinks instantly.
Right. But I'm looking at the layout of this Qatar facility, and my first thought as a builder is, why not just isolate the damaged S4 and S6 trains, valve them off and keep the rest of the massive facility running? It's just one localized impact node. Why does a single hit result in a 3 to 5 year repair timeline and shut down so much adjacent capacity?
You would think you could just patch it, right? But you're looking at it through the lens of traditional modular construction. This comes down to what engineers call the megatrain vulnerability.
Megatrain vulnerability.
Megatrain vulnerability, yeah. An LNG train is the massive complex infrastructure that cools natural gas down to minus 260 degrees Fahrenheit so it condenses into a liquid. The newest megatrains are built for maximum thermal and mechanical efficiency, which means they are incredibly tightly integrated. They rely on a continuous, highly pressurized, closed-loop system of compressors, heat exchangers, and massive turbines.
So it's not like an office building where if the HVAC on floor 3 breaks, floor 4 just keeps working fine. It makes me think of a mechanical luxury watch. You have this multi-billion-dollar machine, incredibly precise, beautifully engineered for peak efficiency. But if you take a hammer and smash one tiny gear inside, the whole thing freezes. You can't just tape it back together or bypass the gear. You have to take the entire watch apart.
That is a perfect analogy. The efficiency is the vulnerability. Because the thermal loops are shared, damage to a single major component prevents the entire train from safely restarting. You have to safely deconstruct, re-engineer, and rebuild massive portions of the facility just to replace one critical node.
Man, that sounds like a logistical nightmare.
It is. And furthermore, this strike completely halted the adjacent North Field expansion project. That is a $28 to $30 billion mega project led by Technip Energies and Chiyoda. All work is stopped, and they're looking at delays stretching well over a year.
Okay, I want to play devil's advocate for the listener here. If you are a commercial contractor based in the U.S., pouring concrete in Ohio or hanging steel in Texas, why should you care about an LNG facility in Qatar? I mean, it feels very far away.
Because of the massive vacuum effect this is about to have on the global supply chain. A 3 to 5 year reconstruction timeline on a highly technical facility of this scale is going to create frantic international construction demand. Qatar will be paying an absolute premium to fast-track these repairs.
So they're just going to buy their way out of the delay.
Exactly. And that effort is going to suck up global materials, specialty steel, high-grade copper wiring, complex mechanical valves, and it is going to draw away highly specialized engineering and labor pools. Even if you are just building a mid-rise in Ohio, you are competing in the exact same global market for those raw materials. You are going to feel this in your material pricing within the next 2 quarters.
That is a crucial takeaway. If you know you need specialty metals in Q3, you might want to lock in those purchase orders today. Now let's pivot, because while global energy infrastructure is freezing up or shifting to emergency repairs, we're seeing a totally different story domestically.
Oh, absolutely. The pivot here is huge.
Right. Builders here at home are capitalizing on an absolutely insatiable need for power. Fluor just signed an LNTP with TeraWulf for a 480 megawatt data center campus in Hawesville, Kentucky, estimated at $3 to $4 billion. Before we analyze the site, what exactly does an LNTP do for a contractor?
So LNTP stands for Limited Notice to Proceed. When you have a massive $4 billion project, the financing doesn't just unlock all at once. An LNTP is a contractual mechanism that allows the builder, in this case Fluor, to begin specific early phase work.
Like site prep.
Yeah, they can start site preparation, initial engineering, or most importantly, order long lead equipment like massive generators or cooling systems, while the final overarching contract is still being negotiated. It buys them vital time on the schedule.
And then the schedule is aggressive. I mean, they are targeting late 2027, but I really want to push back on their location strategy here. They are building this data center on the site of a retired century aluminum smelter. It's a massive plot, nearly 800 acres, with over 250 buildable. But why build a pristine, state-of-the-art tech facility on a brownfield site?
It does seem counterintuitive at first.
Right. Isn't environmental remediation a massive headache for contractors? You're dealing with decades of industrial waste, soil testing, incredibly strict EPA compliance. Wouldn't a greenfield site out in the country be infinitely easier and cheaper to develop?
What's fascinating here is that the physical dirt under the building doesn't matter nearly as much as the invisible infrastructure above it.
Yeah.
It is entirely about the electrical grid. That retired aluminum smelter already has 480 megawatts of existing power infrastructure legally permitted and physically tied to the site.
Oh, wow.
Yeah, smelting aluminum is essentially the process of running massive electrical currents through raw materials to separate the metal. The high voltage power lines, the heavy duty substations, the utility grid connections, they are all already there.
So you can build a server hall in 12 months, but getting a new 500 megawatt connection approved and built by a local utility company from scratch can take 5 to 10 years.
Precisely. In the data center gold rush, power access is the ultimate bottleneck. They are essentially buying the massive power connection, and the land just happens to come with it. You simply could not hit a 2027 completion timeline if you had to start from zero with the local utility. Fluor is managing this entire mega project from their North American data center execution hub in South Carolina, and they are entirely focused on speed to market.
And we know this Kentucky project isn't an isolated anomaly. Data centers are undeniably the hottest segment in the industry right now. If you look at Smart Business Automator's Market Intelligence Report, which tracks these regional data center construction pipelines, the sheer volume of capital flowing into these facilities is staggering. Every major firm is pivoting to capture this demand.
But building a $4 billion data center isn't like building a standard commercial warehouse. You cannot manage a project of this complexity with 2D blueprints and highlighters. To handle facilities where thousands of miles of fiber optics intersect with massive industrial cooling systems, the construction industry is undergoing a serious technological revolution.
Which brings us to the tech side, specifically what just happened at the GTC San Jose conference on March 16th. Procore announced a major partnership with NVIDIA Omniverse. They are essentially creating real-time, live digital twins for construction sites using OpenUSD and NVIDIA libraries to synchronize over 15 different CAD and BIM formats.
It's a massive leap forward.
It is, but I have to admit, I hear digital twin thrown around a lot as a buzzword. How does this actually change the day-to-day reality on a job site?
It solves one of the most expensive and frustrating bottlenecks in complex commercial construction, which is coordination clashes. Historically, you have major software silos. The architects design in one proprietary software, The MEP engineers, the mechanical, electrical, and plumbing teams, design their complex ductwork and piping in another. The structural engineers use something else.
Right, they don't talk to each other.
Exactly. These different software platforms use entirely different mathematical models to render geometry. When you try to merge them to see if the plumbing hits the steel beams, data gets lost, or the file is so heavy it literally crashes the computer.
So the foreman ends up discovering the clash in the field when the concrete is already poured, and suddenly you have a massive change order and a 2-week delay.
Exactly. What OpenUSD does, Universal Scene Description, is act as a universal translator. It allows all 15 of these different proprietary design languages to talk to each other in real time in a single model.
Here's where it gets really interesting. Think about having a living, breathing SimCity model of your exact job site. You can run spatial simulations and find out that the massive HVAC return duct is going to run right through a load-bearing structural beam, and you catch it digitally before you pour a single yard of concrete.
That's the dream.
Yeah, I love the quote from Steve Davis from Procore. He said, "We'll help customers mitigate risk and improve performance in ways that were previously impossible."
And this technological leap extends to the physical hardware as well. Robotics are surging on job sites to handle the sheer scale of these builds. Kawazo just raised $35 million for its LiftBot robotic lifting system. This isn't theoretical lab tech either. It is actively deployed at over 20 industrial sites right now and backed by massive players like Chevron.
The search trends really validate this shift too. Google searches for construction technology are up 190%. The market is officially adopting these tools because they simply have to. But, there's a fatal flaw in relying solely on this new tech.
Oh, for sure, the financials.
Exactly. You can have a perfectly simulated, clash-free digital twin of a building, and you can have robots lifting your scaffolding. But if the macroeconomic math doesn't work, that digital twin never becomes reality. We just saw this exact scenario play out in Milwaukee with a project called the Edison.
If we connect this to the bigger picture, the collapse of the Edison is a glaring cautionary tale. At 31 stories and a $230 million price tag, it was supposed to be the tallest mass timber hybrid building in North America. It was going to be an architectural landmark.
And now, it is completely halted. All they have to show for it is a poured foundation. The post-mortem on this project cites tariffs and material costs, specifically regarding cross-laminated timber, which is highly sensitive to global supply chain disruptions.
Right.
But there is a reported $25 million financing gap. How does a massive, highly publicized project get to the foundation pouring stage, supposedly fully funded, and then suddenly find itself $25 million short?
That is the core issue, and it comes down to how the capital stack on a mega project works. A developer doesn't just get a check for $230 million on day one. Lenders release funds in tranches based on project milestones. Right now, the Federal Reserve is holding rates steady, which keeps borrowing costs painfully high.
So if there's a hiccup, it hurts a lot more.
Exactly. If you are building a highly novel project, like a record-breaking timber tower, and sudden tariffs push your material costs up by 10 or 15%, your total budget inflates.
And the bank steps in and recalculates the loan-to-value ratio.
Yep. The bank looks at the new math, realizes the risk profile has changed, and refuses to release the next tranche of funding. If the developer doesn't have the cash reserves to cover that $25 million gap, the money just stops. But the primary contractor, in this case C.D. Smith Construction, has already performed millions of dollars worth of work. They are left holding the bag.
Which explains the massive legal fallout. C.D. Smith just filed an $11.3 million lawsuit. And in total, 12 different firms have filed over $14 million in liens against the property to try and recoup their losses.
It's a massive cascading failure.
It really is. To make matters worse, the developer lost a separate $700 million redevelopment deal shortly after. So what does this all mean for the listener? If you're out there trying to run a business, what's the takeaway?
It's a cautionary tale about financing risk and payment disputes in today's macro environment. Moody's has just raised its recession odds to a straight 50-50 coin flip. Oil remains elevated, driving up transportation and heavy machinery costs, and material prices are firmly entrenched above a 3% growth rate. We are in a highly volatile environment. Even with massive global offsets like Japan's $73 billion investment, recession signals are flashing red.
So with margins this incredibly tight, a 50-50 recession risk, and material costs constantly rising, How do you actually survive the squeeze? How do you protect your firm?
You survive by knowing exactly where the market demand is shifting in real time, and by violently cutting administrative bloat from your daily operations. You have to do more volume with the exact same headcount.
Let's look at the demand side first, because the search signals are showing a massive, sudden shift in where contractors are focusing their energy. Queries for construction bidding process are up 233%. Searches for construction management software are up 425% for its 11th consecutive day.
Those are huge jumps.
But the most revealing metric is residential estimating service, which is seeing a sustained breakout of plus 42,950%.
That number is just astronomical. It tells us the contractors are scrambling to estimate faster and bid much more aggressively to keep their pipelines full. And we know these exact staggering figures by directly referencing Smart Business Automator's Market Intelligence report. By tracking these specific intent signals, the report shows exactly where contractor panic and demand are concentrated right now.
And that ties perfectly into how contractors are physically surviving this environment. You can't afford to hire 5 new project administrators right now, but you still need to bid on twice as many jobs just to win the same amount of work. So firms are utilizing AI tools to scale their output without drowning in paperwork. Let's talk about how this looks in the field, practically speaking.
Practically, it looks like extreme automation of tedious tasks. AI is automatically tagging and categorizing hundreds of daily job site photos and permits. It is taking those long, rambling voice memos from superintendents in their truck and instantly turning them into clean, structured daily log summaries with assigned action items for the subs.
Which is huge for field guys who hate typing on an iPad. It's also extracting minute details from massive 1,000-page spec books. Instead of a project engineer spending 4 days reading specs to ensure nothing is missed, the AI cross-references the plans to catch missing scope items before they become expensive change orders down the line.
Yeah, that's a massive margin saver.
And the natural language search is incredible. Instead of hunting through nested server folders for a specific email from 3 months ago about a Windows substitution, you just ask the system a plain English question and it retrieves the exact document.
The AI-drafted RFI responses are the real game changer, though. When a project manager is forced to juggle 3 jobs instead of 2 because of economic volatility, having an AI draft an RFI response based on historical project data and current specs saves hours of tedious writing. Add in schedule risk detection, where the AI flags a potential bottleneck, like a delayed concrete pour, before it actually pushes the critical path. And AI becomes the only viable way to manage the chaos.
It's about preserving your margins by protecting your team's time. And frankly, relying on these tracking and management tools is going to become essential because the complex shifts and compliance burdens on contractors are about to skyrocket globally.
Definitely.
We need to do a quick global intel wrap-up to see what's coming down the pipe. Let's look at the UK first. They're creating long-term revenue certainty for nuclear plants via CFD options. Explain CFD really quickly. What does that actually do for a contractor?
A contract for difference is a financial mechanism where the government guarantees a set strike price for electricity. If the market price drops below that, the government pays the difference to the operator. By guaranteeing that long-term revenue, it de-risks massive upfront capital investments. For contractors, this means a sudden, fully funded pipeline of highly specialized facility upgrade work is about to open up.
Meanwhile, in the U.S., offshore wind projects are actually passing major milestones and winning significant court victories, continuing to advance despite heavy local opposition. But domestically on the transit front, the MTA's Second Avenue subway lawsuit is severely testing federal grant limits. It highlights how quickly public mega projects can stall out due to legal red tape.
And looking toward Europe, Norway has launched a major investigation into a fatal 2025 landslide on a railway construction job site. This isn't just local news. This investigation is likely going to trigger a wave of new geotechnical compliance requirements for infrastructure projects globally.
Meaning contractors everywhere will likely face more mandatory soil sampling, delayed excavation approvals, and tighter site tolerances. And speaking of compliance, the Associated General Contractors, the AGC, just announced an Earth Week town hall. They're preparing the entire industry for incoming mandatory carbon disclosure requirements. Every drop of diesel you burn, every ton of concrete you pour will likely need to be tracked, calculated, and reported.
Which brings us full circle back to the software. If you are tracking carbon output, monitoring new geotechnical regulations, and bidding twice as many jobs just to outrun a 50-50 recession risk, you cannot do it with spreadsheets anymore. The administrative burden will simply crush your margins.
We've covered incredible ground today, from the megatrain vulnerabilities in Qatar to the massive digital twin simulations running our domestic data centers. It is a wildly complex time to be building.
It is. And I want to leave you with a final thought to mull over as you head back to the job site or the office. We've talked extensively about how AI and digital twins are simulating complex job sites before they even exist and fixing the gaps in your supply chain. But consider the source of this data center boom. Massive tech giants like Google, Meta, and NVIDIA are funneling billions of dollars into these facilities to power their own AI empires.
Right.
With global energy pipelines being redrawn overnight by missiles and construction margins this tight, how long before those trillion-dollar tech companies decide they don't want to deal with traditional general contractors anymore? The most successful construction firm in 2030 might look a lot more like a tech company that just happens to pour concrete.
Wow. That is a fascinating, slightly terrifying new paradigm to consider. The industry is evolving faster than ever. You either adapt your gears or you let the watch freeze up entirely. If you enjoyed this deep dive, please make sure to subscribe, rate, and review the show on your preferred platform. Share this with your project managers, your estimating team, or anyone who needs to hear it, and be sure to visit smartbusinessautomator.com to learn more. Keep building, stay sharp, and we will catch you on the next deep dive.